All right, we can start the final countdown now. All right, 4 sections left to go. Section 7.2, areas in the plane. So now we're not only going to worry about finding area underneath the curve, but now we're going to talk about area between two curves. Whoa, right? All right, and so we're going to have this thing of having one curve here. Okay, we'll call that f of x, which we do. And we have a second curve here, which we'll call g of x here. And I'm going to find the area between the two. Now, what this illustration up above is supposed to say is, hey, well, what if we went backwards and we start talking about there are little rectangles, right? And we broke this up into little itty-bitty rectangles. And then how could I find out the area of one rectangle? I'm not going to go that far into it right now, okay? If you would like to talk about that, I will. I just thought it was a cool illustration. The main thing that I want you to get across from this is the definition of area between two curves. Well, how do I find the area between two curves? And it says here, if f and g are continuous, where f of x is greater than g of x throughout a to b. What does this mean here? This means that f of x is always on top of g of x. Always. That's what that means. For our interval a to b inclusive. Okay? Means always. Just like the picture here, f of x is always greater than or on top of g of x. If that happens throughout the entire interval, okay, then the area between the two curves, f of x and g of x, is the integral of f minus g, or from a to b, or this equation down here. Okay? Fairly straightforward. F of x minus g of x. And it works. So this is one of those things that if you would like me to go through and explain it through here, I'll be more than happy to. Otherwise, take it on the Church of Math. Just got to believe. All right? Here we go. Let's see it in action. All right, so here we go. I have my first equation. I have secant x and sine x. Find the area of the region between secant squared x and sine x from x equals 0 to pi over 4. All right, so it tells me, well, I need to go ahead and take the integral from 0 to pi over 4. And I take a look, and I go self. Is one function always on top of the other? And in this case, yes, the function is always on top of each other from 0 to pi over 4. Yep, all the way. Okay, so then I go ahead and I find that out. I said, okay, that's good. That looks good. So then I say, well, which one's on top? Well, secant squared's on top. So I'm going to be secant squared x minus sine x dx. And you could always kind of see that right now, right? Because what's the integral of secant squared x? Integral of secant squared x, well, that's all of this area. And then what's the integral of sine x? Well, sine x is just this area right in here. So I'm going to take secant squared and subtract out the sine x. Makes sense, right? So do I have something that can do that? Well, let's think about this here. That can be my antiderivative. So what function, when I take the derivative, gives me secant squared? Oh, tangent x. What function gives me the derivative of negative sine x? Oh, cosine x. Evaluated from 0 to pi over 4. So I plug pi over 4 into there, and I get 1 plus cosine of square root of 2 over 2 minus 0. So tangent of 0 is 0 minus, or plus, excuse me. Cosine of 0, well, cosine of 0 is 1. All right, and then I go ahead and go, well, this is 1 plus the square root of 2 over 2 minus a 1. The 1 minus the 1 cancels out, and I get square root of 2 over 2. And to me, this blows my mind away every time. That's an area. Square root of 2 over 2. It's precise. It's exact. This area inside here is square root of 2 over 2. Mind-blowing. Mind-blowing. Let's take a look at the next one. Okay. So it says find the area of the region enclosed by the parabola y equals 2 minus x squared and the line y equals negative x. Okay. Well, wait a second. They don't tell me where this goes. They don't tell me from where to where. They just tell me find the area of the region that's enclosed by that, the parabola and the line. So on my graphing calculator, I can go ahead and take a look, and I see, hey, there's the area I'm looking for. But I can't find where I'm supposed to meet. How can I possibly do that? And that's the part where you need to find your x coordinates for this intersection. So if this was a calculator problem, you go in your calculator, find the intersection, bing, bang, boom, you're done. But this is not. It's not a calculator problem. So how can I find my intersections? So I do go back to, algebra 2, and I say, well, this would be negative x. I want to say where they're equal, right? 2 minus an x squared. So I bring everything over, so this becomes an x squared minus an x minus a 2 is equal to 0. And I find out it's going to be x minus a 2, x plus a 1 is equal to 0. Therefore, my x's are going to be x is equal to 2 and x is equal to negative 1. And you might have been saying, well, shoot, just look at the graph and tell you. You don't know. All right? Unless they specifically tell you, you need to do it algebraically. Okay? So let's go ahead. So this is what this telling me is that this is my, I want to find the area of these two, between these two curves, between negative 1 less than or equal to x less than or equal to 2. So again, what does that mean? How do I set this up? I got to take a look at, well, which one's on top? Well, the parabola's on top. So it's the integral from negative 1 to 2. The parabola's on top, so it's going to be 2 minus an x squared minus, what's on bottom, negative x dx. And I can combine things the way that they look. I now have the integral negative 1 to 2 negative x squared plus an x plus a 2 dx. Now I'm at a point to where I can go ahead and raise take a antiderivative of this, and this is going to become a negative x cubed over 3 plus an x squared over 2 plus a 2x evaluated from negative 1 to 2. I plug the 2 in to start with. Negative 8 over 3 plus a 4 over a 2 plus a 4. Okay. And I put in the negative 1, minus. And I put a negative 1 in there. So a negative 1 cubed is a negative 1. A negative 1 is a positive 1/3. Okay. Plus a 1/2 minus a 2. And the biggest thing that people are going to mess up on is the distribution of the negative. You have to distribute the negative. All right. So if I simplify things here, this becomes a negative 8/3. 4/2 plus that's plus a 6 minus a 1/3 minus a 1/2 plus a 2. Okay. So now common denominator again. If this is a free response question, leave it. Actually, you could have left it right up there. But this is not a free response question. I'm going to go grab my calculator and find out what that's going to be here shortly. And I find out that the answer is 4.5. Again, truly amazing, right? That something that looks like so arbitrary and so round and everything like this has a nice, pretty, happy number of 4.5 square units. Amazing. Again, units, so I guess technically I need to put units squared. All right, what's next? It says find the area of the region enclosed by the graphs of 2 cosine x and y equals x squared minus a 1. Okay. Again, on this one here, this is a great one to do on your calculator. And we'll show you how that works on a calculator. Why? Because if I was going to set this up the same way, right? 2 cosine x equals an x squared minus a 1. That one is one that you can't really do too easily. All right? So we're going to set that up on our calculator, and I'm going to show you how to do that. All right? I'm going to pause the video and get my calculator all ready to go, and we'll show how that works next. All right, so here's it all set up on my calculator. It's all ready to go. And this right here is the area that we're looking to find. So let's go ahead and find that area, but before I do that, I need to find my intersection points, the one here and the one here. And so when you use your calculator on the test or for this, you need to have precise answers up until the very end. So I'm going to show you how to have precise answers up until the very end, so you're not rounding at every step. Okay, so here's an example of that. So let's go find that first intersection point. So I'm going to press the second key and trace, excuse me, and to find out, I want to calculate an intersection, number 5. It's going to ask me what's my first curve, and it's telling me here 2 cosine x. Yeah, that's the first one I want. Your second curve, yep, x squared minus 1, yep. And then your guess. So there's 2 possibilities here, so I want to make sure let's first go to the one on the lower side, so the one on the left. I go to it. I'm going to click enter. There's my guess, and it gives me the intersection. Now because I'm doing my integration with respect to x, I'm interested in the x value. And this x value is actually stored in x. So what we're going to do is I'm going to show you how to use the store button on your calculator. So I go over here and I'm going to quit, so second, quit. And what I want to do is I want to press the X button. I want to say I want X, and then down here right below natural log is the store button. So I'm going to press store, and I'm going to put it in A. So I'm going to hit alpha, and then the math button, which gives me A. I can put X into A. Pink. And see, there it is, that whole big value. You don't have to worry about copying it down. I go back to my graph, and now I want to do the same thing. I want to calculate my other intersection. And that's number 5. First curve, yes. Second curve, yes. And where am I going to guess? I'm going to scoop myself over to the other side and press enter. And this time it gives me the positive value of 1.26. So great. Again, I want to go back to second and then quit. And this time I'm going to take the same x value. I'm going to hit store, and this time I'm going to put it in B, so alpha apps, and it gives me 1.267. So now what do I want to do? Again, what I'm going to do is I'm going to take a look at, well, which one's on top and which one's on bottom. So in this one, in this section, the cosine graph is always on top, and the x squared is always on the bottom. So when I go and take a look at y equals, cosine is my first one, x squared, so it's going to be y1 minus y2, because y1 is going to be on top. So I go here to second, quit. Now I'm going to do my integration, math 9. And I'm going to go from low as A, so I'm going to do alpha, math to get the A, go up and do alpha apps to go B. And I'm going to do vars, y vars, function, y1, minus vars, y vars, function, push down to get to y2. And you're going to take it with respect to x, and you're going to press enter. And ba-bam, 4.994. Now, this is where you can round. Okay, it's going to, so the 3 decimal, 4.9949, so you can either round to 4.995 or 4. Do not put 5. Okay? So I put that in there. And so after doing this, my integral from a to b of 2 cosine x minus x squared minus 1 is equal, dx is equal to 4.994, or you could put 4.995. Either one would be a correct answer. Okay? Good? That's a great problem. All right, so now you've been shown how to use it on your calculator. Let's go to the next one. So for this next one here, what I want you to do is realize there could be some problems in what they ask for. So let's read this one. It says here, find the area of the region in the first quadrant that is bound above by the square root of x and below by the x-axis and the line x minus 2. So, well, you're going, oh, that's not a big deal, you know, because a lot of people will come here and say, well, just so we're clear, this one right here is y is equal to the square root of x, and this one here is y is equal to x minus 2. And you would say, well, the square root of x is always on top, so square root of x minus 2. And that would be true if I was going all the way over to here. If I was going all the way over to here, where this is negative 2, and then I wanted to do that, and I wanted to get that whole shape, that whole area that you see there, that would be true. But I don't want the whole area. The only area that I want is what's here in green. I do not want this little triangle area down here. Okay? So what can I do? What can I do? Well, what you can do is right here at 2. Look at this piece of the integral, this shaded area here. For this shaded area, this integral represents from 0 to 2 of just the square root of x. Plus, all right, now I have one that's an area between two curves. Here, this was just the area between the curve and an x-axis. This one here is now between the curve and another curve. So now I got to think about which one's on top. So this one here, I'm going from integral of 2 to 4. And you're going, wait, mister, you're supposed to check. Okay, fine. So if I plug in 4 for x, 4 is 2, 4 is 2, yes. This point here is 4, 2. All right, so integral from 2 to 4 of the square root of x minus the quantity x minus 2 dx. Oops, forgot my dx here. So it's two separate integrals that we're doing this for because it's two separate problems. All right, so I'm going to pause the video. I want you to figure out the rest of this from here and see whether or not you get the right answer. Okay? And when you come back, you'll see if you got the right answer. All right, well, good luck. We'll see you on the flip side. Bada bing. There it is. All right, now it does look like a lot of work. Okay, I spelled it out pretty straightforward as far as how this would go. Follow the work. If you have questions, you always can talk to me. All right. So, next up, as long as you got 10/3 answers. Finally, next up, homework. Okay. So what I want you to do is number 1, 2, 5, 13, 18 with a calculator. Okay. So use your calculator all day long. Go ahead, pound it out. All right. Use your calculator. I want you to be able to get used to that. Next, number 6, number 10, I want you to do it without a calculator. All right. I want you to do that one by hand. All right. Well, that's about it. We'll see you guys for the next video. Talk to you guys later. Bye.